In this lecture, I'm going to talk about timelines. Timelines are used to create simple animations, such as changing the location, rotation, or color of an object. To add a new timeline node, all you need to do is right-click in the graph and select Add Timeline from the bottom of the menu. And you can give your different timelines different names. I'm going to name this one Timeline Light Intensity, because I'm going to use it to gradually adjust the intensity of a light source on my level. And now to edit this timeline, I just need to double click it to open it in the timeline editor. The first thing I'm going to want to do is use one of these buttons here to add a new track to this timeline. A track is used to specify what value or values the timeline should be outputting at any given point in time. The first button with the F on it is used to add a new float track, which is used to animate single float values. The intensity property of a light source is a single float value, so this is the track I want to create. And I'm going to name this track Intensity Value. So a track is represented by a graph. The time in seconds from the start of the animation is represented horizontally. The value that is outputted is represented vertically. So to specify what value should be outputted at what time, you need to add a key to the track. To add a key, hold down Shift on the keyboard and left click in the graph. To change the placement of this key, I can either left click on it and drag it to where I want, or I can use these boxes to enter the X and Y values manually. And if I want to move around the graph, I can right click and drag the mouse, and if I want to zoom in and out, I can use the scroll wheel of the mouse, just like in a blueprint graph. Okay, so I want my light to start out completely dark at first, or in other words, have an intensity of 0. So I'm going to set my first key to be at time 0, which represents the exact moment the animation starts. And as I said, I want it to start out completely dark. So I'm going to specify that at time 0, I want the value outputted to be 0 as well. And now I want it to stay dark for a second before the light turns on, so I'm going to add another key, set its time to 1, and set its value to 0. And now I want the intensity of the light to gradually increase until it reaches a certain amount. And I want it to reach this maximum amount halfway through the time remaining in the animation. So the length of the animation can be set up here. Right now it's set at 5 seconds, and my last key is at 1 second, so there are 4 seconds left in the animation. So I'm going to add another key, and I'm going to set its time to 3 seconds. Okay, and this moved the key off the screen. So I'm going to click in an empty part of the graph to deselect all keys, and then click this button here, which will zoom in or out to fit all the keys on the screen horizontally. And as I said, halfway through the animation, I want the intensity of the light to peak. So I'm going to set the value of this key to 200. Unreal Engine measures the intensity of the point light in candelas, and 200 candelas is plenty bright for this demonstration. Okay, so that moved the key way off the screen, so I'm going to click this button to fit all keys on the screen vertically. Okay, now at this point, I want the intensity of my light to start decreasing until the light is essentially off again. So I'm going to add one more key, and I'm going to set its time to 5, which is the very end of this timeline. And I'm going to set its value to 0. And then I'm going to click the Zoom to Fit horizontal button again. Alright, so this line here, known as the curve, represents what value the timeline node will output at any given time during the animation. At the start of the animation, the timeline node will output 0, and it will continue to output 0 for the first second. Then, for the next 2 seconds, it will gradually output a higher and higher value, until at 3 seconds into the animation, it is outputting a value of 200. Then, for the next 2 seconds, this value gradually decreases until it reaches 0 again. Alright, and this value gets outputted from this pin over here on the timeline node. For each track you create, it will create a new output pin on the timeline node that will output the value for that track. So what I want to do is to connect this pin to a node that will set the intensity property of my light. So I'm going to go back to the level editor, and I'm going to drag a light into the level. and I'm going to name it My Light. And with it still selected, I'm going to go back into the level blueprint, and I'm going to right click in the graph, and with context sensitive checked, I will have the ability to create a reference to My Light. So now I'm going to drag off this pen and create a set intensity node. This node will set the intensity of whatever light is connected to it to the value specified by its new intensity pin. So I'm going to connect the output of the track I made to this pin. And I'm going to connect the update execution pin to the set intensity node. The update pin will fire for every tick of gameplay while the timeline is playing. And finally, I'm going to connect the event begin play node to the play execution pin of the timeline. Okay, so now when the level begins, it will cause the timeline to start playing. So then for the next 5 seconds, which is the length of the timeline, for each tick of gameplay, the update pin will fire, causing the set intensity node to fire. And each time the set intensity node fires, it will receive a different value from the track based on that track's curve and the current playback point of the timeline. So let's see how this looks. So when the level first starts, it's completely dark, and then the light gradually gets brighter and brighter until it reaches peak intensity, then it grows dimmer until it goes out completely, and the whole thing takes exactly 5 seconds. Alright, so that's the basics of how timelines work. You create a curve on a track to output different values across time, and then use those values to update some property during each tick of gameplay. So now, let's look at some of the options we have available when working with timelines so that you don't screw up your timeline as bad as Marty McFly did. So I used this float track to change the intensity property of a light, but I could have used it to change any property that is defined by a single float value. If I wanted to create a track to change a vector value, such as an object's location, I would use this button to create a vector track. And by gradually changing an object's location over time, I can create a simple movement animation. Okay, and then this button here is used to create an event track, which can be used to specify at what points in time certain events should fire. This button is used to create a color track, which can be used to gradually turn one color into another color. And then this button here can be used to add an already existing curve to a new track. So you can save curves you create and use them again later. So if I right click in the graph, I can select Create External Curve to save this curve I made as an asset in the content browser. And then if I selected that curve asset in the content browser and clicked this button here, it would create a new track and add that curve to it. If I want to add an existing curve to the current track, I need to select the curve in the content browser and then click this arrow here in the track I want the curve added to. If an external curve is already loaded here, you can click on the magnifying glass to select it in the content browser. And then clicking on the X button will convert this to an internal curve again so that it can be edited. Alright, so now I'm going to add a second track to this timeline, and then you'll notice that when I pan or zoom one of the tracks, it will do the same thing on the other track. And that's because both these tracks have synchronized view checked. If I uncheck this, the tracks will now pan and zoom independently. And then if you want to change the order that the tracks are listed, you can use these up and down arrows here. And then back up here to the right of the track buttons, there are a few options you can set for your timeline. Again, you can set the length of the timeline here. And then to the right of that is the Use Last Keyframe option. If this is unchecked, the very last tick of the animation will be ignored. This is useful when looping to prevent skipping in the animation when the loop starts over. If the autoplay option is checked, the timeline will begin playing as soon as the level begins, even if it's not connected to the event begin play node. With the loop option checked, the animation will start over from the beginning once it reaches the end. The replicated option will cause the animation to be replicated across all clients during a multiplayer game. The next option is Ignore Time Dilation. So time dilation is a feature of the engine where you can slow down or speed up time in your game. So with this option checked, the timeline will ignore any time dilation settings and just play at normal speed. And then finally is the tick group option. So again, the timeline will output a value during every tick of gameplay. The tick group option allows you to specify when during this tick the next value should be outputted, and there are 4 tick groups to choose from. You can choose to have the value outputted before any of the physics data for the next frame is updated, while that data is being updated, after all the physics data has been updated, or after almost everything else in the frame has been updated. Alright, so now I'm going to go over the pins of the timeline node itself. So when the play pin fires, the timeline will start playing from its current position. So let's say the timeline starts at 0 and the play pin fires, and then 2 seconds into the animation the stop pin gets executed. At that point the animation will pause at the 2-second mark. If the play from start pin was executed, the animation would go back to the 0-second mark and play from there. But if the play pin was executed at that point, the animation would continue playing from the 2-second mark. The reverse pin will cause the animation to start playing in reverse from its current position, and the reverse from end pin will move the animation to the end and then start playing in reverse from there. The set new time pin will move the animation to whatever time is specified in the new time pin. The finished pin fires when the animation is complete. And then the direction pin will contain an enum value of either forward or reverse based on which direction the timeline is playing at that particular moment. Alright, so now I'm going to close out the lecture by going over something called a lerp node, which is commonly used in conjunction with timelines. So lerp stands for linear interpolation, and its node can be found in the math category of the node menu. And actually there are different lerp nodes based on the type of values you are working with. I'm currently working with float values in this example, so I'm going to select the lerp node under the math float category. Okay, so how do lerp nodes work? The basic idea is that you enter a starting value in pin A and an ending value in pin B. Then you enter a value between 0 and 1 into the alpha pin. This number represents a percentage, so 0 represents 0%, 1 represents 100%, 0.5 represents 50%, and so on. So if you imagine value A as the starting point of a line and value B as the ending point of a line, the percentage you enter will tell you what the value is at that point on the line. So for example, if the alpha pin has a value of 0, this node will output the value in pin A. If the alpha pin receives a value of 1, the node will output the value in pin B. If the alpha pin receives a value of 0.5, the node will output the value that is exactly halfway between the values of A and B, and so on. So to give you some examples with actual values, I'm going to set the A pin to be 0 and the B pin to be 4. Okay, so now with A set to 0 and B set to 4, if I enter a value of 0 for the alpha, the return value pin will return a value of 0, because 0 is 0% between 0 and 4. If I enter a value of 1 for the alpha, this node will return a value of 4, because 4 is 100% between 0 and 4. If I enter a value of 0.5 for the alpha, the node will return a value of 2. Because 2 is 50% between 0 and 4. And if I enter a value of 0.25 for the alpha, the node will return 1, because 1 is 25% between 0 and 4. Okay, so that's how lerp nodes work. Now let's look at one example of how they can be used, particularly how they can be used in conjunction with timeline nodes to give you a little more flexibility. So right now, I have this light which is going from a minimum intensity of 0 up to a maximum intensity of 200. But what if I wanted the player to be able to change these values in the game? Like have the character interact with some control dials that can set the minimum and maximum brightness of the light. Well, right now, there's no way to do that because I have those values hardwired into my timeline curve. But I can solve this problem by using a lerp node. Instead of hardwiring the values in the timeline, I will create variables for these values that will be plugged into the A and B pins of the lerp node. And the timeline, instead of its curve representing absolute intensity values, will instead represent the percentage of the intensity to be used. So its values will range between 0 and 1, and its output will be connected to the alpha pin of the lerp node. Okay, so first I need to create the variables. So I'm going to create a float variable called minimum intensity. And another float variable called maximum intensity. I'm going to set the default value of minimum intensity to 0, and I'm going to set the default value of maximum intensity to 200. And I'm going to connect those variables to the A and B pins of the lerp node. And now I'm going to go back into the timeline editor, and I'm going to change the value of the second key to 1 so that the curve now goes from 0 to 1 and then back down to 0. And now I'm going to connect the track pin of the timeline node to the alpha pin of the lerp node and connect the return value of the lerp node to the set intensity node. And then connect the execution pins. So now the timeline node will output values from 0 to 1 and back down to 0, which will cause the lerp node to output values from 0 to 200 and then back down to 0. And so now if I run this again, it should do the same thing as before. Okay, so both of these examples do the same thing. The first is a little more straightforward, a little easier to understand, while the second example gives you a little more flexibility over the values being used. So whichever method is best will depend on the situation. Alright, and that will conclude the lecture on timelines.